Okay, today is day 7 on vectors. It's the last day of this lesson right here, and this is a vector. It's in vector form. You can make it in parametric form pretty quick and easy. Okay, and then after that you could change it from parametric form by getting rid of the t. Then you just have x's and y's and z's. All right, and that would be not vector form anymore, not parametric form anymore, but it would be Cartesian. All right, good. So the thing you haven't learned is about speed. If you think about this, this just tells you where you start. It has nothing to do with your speed. Your speed is how far you go in a period of time. So distance equals rate times time. And if I want the speed, that's the rate. Divide by t, divide by t. To get the rate is the distance divided by the time. And so it's really, really simple. If I do time 1, I need to know what it's in, like 1 minute, 1 second, 1 hour, whatever. But if I do time 1, then I'm going to travel this distance. How do I get a distance out of this? I do its magnitude. So how do I do the magnitude of that? It's the square root of that squared plus that squared plus that squared. So 1 squared is 1, 0 is of course nothing, and then 7 squared is 49, 49, and then 1 makes 50, square root of 50. To get that just a little more than 7 distance. The square root of 49 would be 7. This is like 7.1. So then what is that for speed? 7.1. And what was I going in? Feet, miles, inches? I didn't probably tell you, so I'll say feet. So that's about 7 feet per second. Square root of 50 is the exact answer. All right. So I'd like you, let's say this is your problem, 143 plus lambda 1 negative 6, 2. Don't forget that negative just means it's a direction thing, and when you square it, it won't make a difference on your magnitude. Would you tell me how fast this thing is going if I was doing my time in seconds and my distance in feet? How fast is this thing going? I'll pause, we give that a shot. Okay, that shouldn't have taken too long. That tells us our magnitude. Square root of 1 squared, 6 squared. Why didn't it say negative 6? It's not squared anyways. And then 2 squared, and that's going to make 36 and 4 and 1. That's square root of 41. But if I just said that, you lose, because you should have said that in, what was it again? Meters per second. And if I say you're going the square root of 41, that could be a zillion things. It could be miles per hour. And let's just figure out what it is. What is it about? Well, 6 squared is 36, so it's a little more than 6. It's like 6 meters in 1 second is actually a decent distance for 1/1000 to go 6 meters. It's going decently fast. Okay, but if it was in miles per second, there are things that travel that kind of speed, 6 miles per second, 1/1000, and they go 6 miles. It's hard to even imagine, but there are things that are hurtling at that rate around our planet, for example. Things travel so fast that you do it in thousands of miles per hour. So, and you can get just ridiculous speeds out in space because there's no what? There's no gravity, or at least there's very little effect of gravity. I mean, there's gravity out there, but and there's very little effect of friction out in space. So if you don't have friction slowing you down, just think about it. If you're rolling a ball, it would like never stop rolling. Normally you roll a ball and it slows down, and stops. Okay, but if you're out in space and you throw that, it doesn't stop. It doesn't slow down. Now there is all kinds of crazy stuff happening in space, just to clarify. It's messy. There is radiation out there, there is solar winds, there's particles. Anyway, I'm not trying to say that there's nothing out there. It's not quite that simple. There's other things to stop you. All right. So speed is just the magnitude of this guy. That's the only new thing I really needed to get across. But the hard thing I taught you yesterday bears some repeating. And that was, if this, for instance, this blue thing, is an equation, if I gave you another equation like it, you'd be able to tell me whether or not the two intersected. Do you remember the first thing you did was make it into parametric form? All right. I'm not going to do this one because I have a problem all set up for you. And I'm going to start you with an easy one where it's just got x and y, not x, y, and z. This one, I will tell you, it will intersect. And you just have to see if you learned how to do parametrics and then set the x part equal and the y part equal. And then you'll have two equations. You have to solve a system of two equations, and then you'll have your answer. All right, so this one works out. I will tell you, they will cross. So my question is, do you know where they cross and at what times the paths cross? And then why would we need to know the time? Because if they're not at that same spot at the same time, then that means they would not collide. They may cross the same path, but if they're not there at the same time, they won't collide. All right, I'm going to pause, give you some time, see if you learned how to make parametric equations and set them equal to make a system that you can solve. And again, when you're done, if you just say, oh, Mr. Server, the t is 1 and the lambda is 3, you haven't told me where they crossed. You got to get the times and where they crossed. I'll pause. We'll give that one a try. Done. All right, first I'm going to make my x. X equals 1 plus 3t. Y equals 2 plus 2t. My t got a little funny there. I'm going to fix it. Because sometimes just that is enough to throw you off a little bit. All right, now I'm going to make my equation for the lower one. X equals 6 plus negative 2 lambda. Now, plus negative 2 also could mess somebody up. That just means minus. And then y equals 0 plus, I don't really need 0 plus, 4 lambda. Then, did you know enough to set x equal to x? And I have 1 plus 3t equals 6 minus 2 lambda. Raise your hand if you had that right. Good, that's what you were supposed to do. Now, I can solve it for something. I can either solve it for lambda or I could solve it for t. I'm going to solve it for t. All right, I'm going to subtract 1, and that cancels. 3t equals 6 minus 1 is 5 minus 2 lambda. And now I'm going to divide by 3. And there, I have solved for t. Why did I do that? So I can put it in the other equation. When I see the other equation, I'm referring to this going with this. So that one says 2 plus 2t equals 4 lambda. And now that I know t is all that, I can put it in here. And so I go 2 plus 2 times all that, 5 minus 2 lambda over 3, equals 4 lambda. And now it's only got lambdas in it, and now I can just solve it down. Who has already solved it all the way down and has the answer? Raise your hand if you have that. Just raise it high, because I can't tell if this is really only like 4 people. Okay, all right. Looks like about half the class, a little less. I'm going to subtract, wait, I'm going to start by multiplying this out. 2 plus, I'm going to multiply this out and get 10 minus 4 lambda over 3 equals 4 lambda. That was me distributing out my 2. Notice I only do it on the top. Do you get if I multiply by the 2 on the top and the 2 on the bottom? I really multiplied by 2 over 2, which is actually 1. So I don't want to do that. Just multiply across the top. Now I'm going to get rid of the 3. I'm timesing everything by 3. I've trained you to get denominators cleared. It's a good idea. That's gone now. 6 plus 10 minus 4 lambda equals 12 lambda. It takes a while to grind out this old algebra. So I'm now going to add 4 lambda plus 4 lambda. And now I have 16 from these two equals 16 lambda. Oh, that worked out pretty good. Lambda is 1. Raise your hand if you had. Lambda is 1. All right. Now, once I know lambda is 1, does it mean it automatically worked? No. It's a good sign that it came out to a whole number, but that does not make it a lock that it worked. Well, now I find another equation where I should put lambda is 1, and I'm looking for one that would be simple to do. I guess this one's not too bad, where I could put lambda is 1. If I put a 1 right there, I have 5 minus 2 is 3. 3 over 3 is 1. T equals 1. You see how the second one is so much quicker to get? So lambda is 1, t is 1. What does that mean? That means that they were in the same spot time was 1 at the same time. But now what was that spot? You take the 1 for t and the 1 for lambda, and you go back to the original, these two guys. It's the easiest, I think. And I'm going to stick in a 1 here and here. And this will tell me where they hit. How many of you already had where they hit? Just to know, like good. All right. So then it should have been 4, 4. Because 1 plus 1 times 3 and 2, 1, 2. 4, 4 is the spot that they hit. How do I say that they hit? Because they were there at the same time. If you are going through the intersection at 7 and 101 at the same exact moment as another car is going through the intersection, if you're in the same spot at the same time, that means you're going to crash. Okay? So, all right. If you're just a split second behind them, that's all it takes, and then you're in the intersection at a slightly different time. So you're okay. All right. That's one with 2D. Now here's one with 3D. I have pre-designed this to work. And XYZ equals 1, negative 1, 1. Plus, I wouldn't write these down if I were you. I'd just write the parametrics right off the bat. Just write the parametrics for it. Then I'll make the other one in black here. And it is XYZ. Negative 8, 1, negative 2. Plus mu 5, 0, 2. I especially was nice to you by putting in a 0 in this. Why? Because when you write the equation for that, do you get it's just going to say y equals 1. And boom, you know y equals 1. Then you can go stick in another equation, and things are going to drop really quick on this one. All right, so first, write your parametric equations, one of which is in that black one where it comes out to y equals 1. But write your 3 parametric equations for each. An x equation, a y equation, and a z equation. And solve. Find where did they hit, or actually it's really where did they cross paths, and were they there at the same time? I'll pause, we give that a shot.